people, 2017. It's a horizon speech. Horizon speech is not a common term that's being used in Asia, right? In Asia, we tend to use more keynote speech and the plenary address. Firstly, before I go any further, is my audio loud and clear enough? All right, good. It's a hybrid Asian and Australian accent, if you can pick that up. Right, wonderful. I'm very excited about this title, about, in the age of digitalization, how it will actually affect our research, and also about, carrying out knowledge services as a practitioner. As Mr. Schofer said, in fact, this very year is precisely where I spent 16 years in industry and 16 years full-time in university, right? So I'm not sure which balance will I tip after this, but it's half bucket of water in each camp. What that also means is it's never a full bucket of water. All right, so the way I think I will carry this out, and hopefully it will inspire everyone to think together with me, to brainstorm, so that each and every one of you would also map out your own, indicative directions for where things are going. This is what I like to, share with my students as well. Is start talking about what the age of digitalization is like, especially in the huge explosion of data and the speed in which data is coming through. And then we start talking about, for example, I strongly believe actually the cloud. If we take a reframing of the cloud computing, right? In fact, it's a lot more superior than what we believe that people are currently using cloud computing, right? When I get there, hopefully I can, inspire and inject that additional dimension of thinking into everybody. Then we move into talking about how do we actually orchestrate in future knowledge services, even human-to-human connections via the cloud, and this is where I think this is very exciting. And this is not, science fantasy. In fact, for the examples I'm going to give you, each and every one of us has already been, participating or providing some kind of knowledge services via the cloud. We may not know it, but I will give you clear evidence so that before you have the barbecue, you appreciate that, we are an agent to that ecosystem. And then we finish off with, if we are to embed, knowledge services in the cloud with the advancement of artificial intelligence and many other things that is confronting us right now, do we just merely port human knowledge or try to codify as much as possible human knowledge into the cloud? Well, maybe, perhaps, but just wait. We also learned that early results from big data has already given us some clear indications that we do not, as human beings, we do not port or directly port much of our logic, understanding, and mental model directly into the cloud. In fact, for human beings, I can deduce to you that there are several things that we have to unlearn and learn again before we can accelerate our power and collective wisdom in the cloud. All right, so that's the tech that we're going to take. Hopefully, everyone is with me. Well, digitalization, this word called digitalization, and you can no doubt appreciate that, as my background was communicated to you, it's not new to me because some 30 to 35 years ago, I was already pursuing PhD research in the area of artificial intelligence and also expert systems. And I remember at that time, late 70s, early 80s, digitalization as a word also around. What was that referring to? Well, I can recall that at that time, it was very much about office automation. It was very much about converting paper-based documents, paper-based material into some kind of electronic form and store it. All right, as time progresses, it got a little bit more advanced, like, for example, putting documents, electronic documents, not only just, imaging, but also converting into searchable text, the process of OCR, optical character recognition. And we still do that, pretty much automated by machines these days. But this time, this era, when digitization come back to us in a big way, I can see that there are some major characteristics that will, makes the wave of digitalization far more impactful in our life. The first one is the huge amount of data that's coming through. Later on I will show you with statistics about how fast and how big volumes of data are coming through, and there are major impacts that on us, on our life, on our ability to generate knowledge, on our ability to learn, to share, on our ability to assimilate whatever being distributed, even in the public domain, into our mental model. And as I said, this amount of data and knowledge is coming through at a phenomenal speed, right? When, data is being generated at a phenomenal speed and in a big volume, if we are to ride on top of it, what are some of the issues confronting us? Storage, which part of the data that we should collect, what data we should analyze, and are our existing computational power and algorithms fast enough in order to process that? If not, what are the alternatives? Should we still purely rely on computers? Even if I say that computers, even the fastest computers is not fast enough. Later on we'll see that in fact there are some problems, there are plenty of problems that human beings are still much, much, much superior than computers. On those occasions, the artificial intelligence should basically decompose the problem and split it into at least two different channels to solve. Those that have been automated, go to automated computers, server farms to fix it, the algorithms that are already been pre-programmed to do it. Those that require human input, go to humans and go to millions of humans, right? The massive scale. And then we left us in the middle, which is, the cooperation between human and machines in order to find the final solution. The third element, it's about the combinatorial effect. Living in the age of digitalization, trading, generating products and services in the age of digitalization, it's very challenging, very satisfying, but it's also very punishing, right? Punishing because in the age of digitalization, the winner takes all. There's no second prize. In the world of apps, people can launch apps. Successful apps can be downloaded millions of times in a very short period of time and can be combined, disassembled, reassembled to form other types of apps, right? So if yours is not as good as that, you're just being left behind, blind me, by miles, right? So in a large-scale perspective, the winner pretty much fetches about 95% of the reward, right? But in the analog days, in the old days, you still got small shops being able to compete in certain ways, but not in the age of digitalization, not here. So allow me to say a few words about cloud computing. And today is, in the year of 2017, cloud computing as a term is not new, no matter which continent I stand on, right? I think most people would have probably read or come across this definition before. If you read this definition, which is authentic, true, and correct, right? It kind of focuses pretty much on the technical and the infrastructural aspect of cloud computing. Is that right? It's talking about, connecting together resources, right? Primarily IT resources, can be other resources as well, and provide a common pool of these resources as different types of scalable services to anyone who has been pre-authorized to use it, right? So it sounds good, and it's good, right? Now, I'm not going to log into a debate about whether overall the cloud is going to be economical or not, then alternative computing measures. Time will tell about that. But in this definition, it kind of makes us too overly focused just on the provision and the fast provision of scalable IT resources, right? There are other things which didn't come through, and I will take you through a reframing later on so that you can see that, wow, that's pushing things to the edge of the envelope. That's the future with the cloud, right? But just on this one, there's another element that maybe you spot. We haven't talked about the payment aspect. The payment aspect. What about in the cloud? How is it different from operating in a non-cloud environment? Anybody knows? Or anybody wants to volunteer? Yes, please.
It's pay on demand.
Pay on demand, exactly. What about the timing of the payment? Instantly? Well, you can do better. What about electricity here used by the Institute? I don't think it's being paid instantly. Peter, is that right? It's being paid afterwards. It's post-pay, right? Now, that's already a big advantage, especially for small to medium-sized enterprises, because it frees them up from spending or finding a huge sum of money to start up, and they can pay they only need to pay after they have used the services, right? Is that an advantage? That's a big advantage, not just in terms of the payment, but in terms of taking risk. Already, the cloud is removing some of the business risks that many small businesses have to face before. Because you can start campaigns of competition, you can start campaigns of massive marketing or whatever you want to do via the cloud, and you only need to pay when there's a big flock of audience coming to use it, right? What happens if with very little people come to use it? You don't have to pay for it, right? In the alternative framework, there's no such thing. You have to, if I put, this is a bit embarrassing, most university environments, if you want to buy a PC, you have to find a budget, you have to find a form to fill in, I think, and then you have to find people to authorize it, and then you have to order it, and when it comes, that's a lag of several weeks, it can be worse, and then whether you use the PC or not, doesn't matter, you have to pay first, right? So that's a far cry from the cloud's characteristics already. So needless to say, the businesses and individuals capitalize on it, and they realize that the cloud is scalable, very good. It helps organizations to be more agile. It's provided as broadband services, and all in all, it's good. And there's more, So if you are with me, we all agree that with a cloud, it actually connects, right, computers and stores data at a massive scale. I think if you look at it from an IT perspective, that's pretty much true, right? A huge connection of network and computers with software delivering services. And it stores a huge amount of data and documents as well. So I think today in all continents, many businesses have been leveraging the cloud or this kind of increasingly types of commodity types of services, like disaster recovery, storage, email archiving, and so forth. Maybe newer usages of the cloud are video conferencing, and I would say that process management tends to be a more advanced use of the cloud, right, than the others. Because the others are basically just providing resources, but process management, if you run, for example, a cloud service and you provide process management, you have a lot more to gain than just providing that service. Anybody knows, or anybody can trigger that thought? If there are 20 companies represented here, right, and each company use their own process management software, then each company will manage their own processes and generate their own statistics for improvement, right? However, if a number of companies have joined a common cloud service, assuming that the privacy and the confidential data is being maintained, right? Then, for example, 6 companies in this cloud using the same process management services, then company A, B, C, D, E, F. If I'm company C, I can ask the provider, can you benchmark my performance as per the process, as per this group of people, as per whatever I want to do with the other companies, even they remain anonymous, right? So as a cloud provider providing process management services, you can provide additional type of comparative benchmarking and analytical services and have more business opportunities to gain already. But still, that's not what I'm trying to get at. Later on, in 5 minutes, we'll push things further to the edge of the envelope. Web 2.0, it's been around for, today, 10, 15 years, right? What's one word that we can represent the key characteristics of Web 2.0? No, that's a example website of Web 2.0. The nature, the characteristics, just one word, English word. Start with an I. Interactiveness. Exactly, interactiveness. So Web 2.0 has done a lot of good things for KM, for knowledge management. Why? Because it offers the bottom-up channel for two-dimensional flow of information, right? If company adopts it, but many individuals adopt it already, right? So I always ask my students to think about, don't just go for the cloud because there's the cloud. Can you actually differentiate between, what's the difference between the web, the internet, in other words, Web 2.0, and the cloud, right? The cloud, is it just a newer and more fashionable concept? I think it's a lot more. Because the cloud, as the way that I described it just now, provide more integration A lot more than just the volume aspect. And the integration, the tools, and also the processes to control, to contain, to manipulate, to analyze a much larger volume of data, right? So the cloud is a lot more powerful than the web. If you look at good examples would be the social cloud. Although they are not all integrated, but the social cloud, for example, Facebook, Instagram, and all those, they are providing more and more tools for people to use, empowering the users to become more and more personalized and be able to do more and more things that hopefully would attract them to at least remain or even become a paying subscriber for using those social cloud. So integration, the ease of use, and also access to the huge amount of data, both by the user and also by systems, tools to do the analysis are the much bigger gain with the cloud. But can we expect more from the cloud? Can we expect more? So far, we've been talking about, social cloud, Web 2.0 software, Facebook. We've been talking about, the cloud provides scalable services, much larger scale. The cloud contains a lot more computers to store data, all right? It can do analysis and so forth. Can we expect more from the cloud? In fact, I've been, dropping some hints to everybody. Well, more hints are forthcoming. In fact, this is no longer an idea. I'm starting to see firms, industry, organizations starting to realize that they can actually tap into the cloud and be able to do more. Right? More than just providing the fundamental IT and business commodity type of services. More than just storage, more than just email archiving, more than just hosting collaboration software, and so forth. Some ideas, can we actually embed intelligence in the cloud? Can it be intelligence in the cloud? Right? Think about it. I think that there's already a lot of intelligence that can be accessible via the cloud. What's this pattern? Flying birds, of course. The name of the bird, sterlings, little birds, right? Near dusk, they fly sometimes in big patterns, right? Obviously, they learn it from somewhere. Sometimes they fly like a big farmer. Sometimes they fly like a big bird, like a big eagle. Why are they flying in these patterns? Swarm intelligence. That's right, to deter the prey, right? To make them more threatening, much larger than a human as well. So little birds, they are not intelligent, but at least they have the mini logic or knowledge of flying to maintain the order, yet showing a cohesive, much bigger shape to accomplish the purpose. So there's much to gain and think about this. I mean, there's also videos on YouTube that you can see about this phenomenon called murmuration, and try to trigger us to think that, is it possible that we can build intelligence into the cloud so that it exhibits this, right? A large-scale problem, we can have the problem decomposed into smaller problems, and some being solved by humans, some are being solved by computers, and there's a way to compose it all together for the final solution, right? So that's the leadway and the reframing into the cloud. Again, think more about the cloud. Can we draw intelligence from the cloud? Here's the turning point, right? The answer is obviously yes, because let's flash back. And Mr. Shover said that, that's a good test to ask everybody. What were the two areas that Mr. Shover said that talked about my research areas? Nobody remembers. Very good. Prof. Hisik, blended learning. Second one is KM Technologies, right? All right, so KM Technologies, right? Everybody knows. If you're from the KM team, if you engineer a KM system, okay, I need to be careful. I do mean a technical system, because 20 years ago when I was teaching at Australia, I was very excited about KM system. And then a student came to see me 20 years ago. He said that, Professor, our company has developed a KM system. Wow, I got so excited. I said, tomorrow I won't go to work and allow me to come into the company. I want to look at the system. Let me press a few buttons, because 20 years ago. And then what's his response? He looked at me very seriously saying that, what do you mean? It's not a technical system. It's a paper-based system that we capture information, somebody analyze it, and then somebody write down some aggregator figures, and we provide that as an opinion to make decisions for our client. Well, he is right, right? So you see, he shot me down in 2 seconds. A KM system, don't get too excited. It may not be a technical system. Ever since then, 20 years, I learned from this experience. So this time, I do refer to a technical KM system. Now, to be honest, as a KM professional, as a KM practitioner, would we call a KM system to be successful if it's being launched on day one, let's say 1 or 2 weeks, and this is a new system, and we ask users to use it? Do we declare a success? How many think that you say yes? It's a no, right? Why? Because you don't measure the success of KM system shortly after the system has been launched. You measure it on an ongoing basis, especially you measure it for sustainability, right? No matter whatever system you develop, if it cannot be sustained over a period of time, and that remains to be decided, I would say that we are talking about at least in terms of years, right, rather than months, then you wouldn't call that to be a KM system, okay? Otherwise, you're just cheating. All right, so flashback to the cloud. Exactly the same, philosophy to apply it. A cloud is not a cloud if it is only have its own IT infrastructure, networking, data, whatever. You can talk about a big storm about it, but it's still not a cloud, right? Unless the cloud has attracted a huge volume of users. So, what was your example before when I said that, examples of Web 2.0? Facebook, the Facebook cloud, the social cloud. Why is it so successful? Huge volume, right? Huge volume of people, huge volume of data, and very capable, tools for analyzing this data for continuing advancements, right? So therefore, we wouldn't call, I hope you agree, we wouldn't call any sort of KM system to be successful. We wouldn't call any sort of cloud to be successful unless it has amassed, it has attracted, right, a huge volume of data and people, right? So only then we call it a cloud. Aha, well, if that's the aha moment. If that's the case, then you realize the cloud is more than just connecting people and data. The cloud is just connecting computers. Again, is it possible to rewind YouTube? A cloud is not just connecting computers and data. A cloud is connecting people and computers and data at a massive scale, right? So flashback to all the social software cloud, which is a very good example. We are talking about millions, in some cases like Facebook, billion number of users. So what are the, for example, that's very good. It's a blank one. So again, stretch your mind. What are the types of connections inside the cloud? Make it simple, very simple. At 7 o'clock, our thinking juice is drying up. What are the types of connections inside the cloud possible, right? I'll give you the first one. Machine to machine, right? Second one? Very good. In fact, you're too good. Second one, if I use it logically, is machine to people. And the third one, people to people, right? Why is that? Machine to machine, of course, anyone can imagine that based on the definition. Machine to people. Didn't I just say a cloud is not a cloud unless it's got a very successful subscription and adoption? So successful, we are talking about millions, hundreds of millions, and in some cases exceeding billion. Right? What's the first step you need to do when you need to use the Facebook cloud? What's the first step? Assuming that you have never used it before, which is hard to imagine. Is it coming in Germany? Yeah. Facebook? Yeah. So what's the first step? You need to create an account, right? By creating an account, you have made a connection, fortunately or unfortunately, between you and the Facebook software. And where's the Facebook software being installed? Inside the Facebook cloud, right? So that's the second type of connections. So is there a third type of connection? Yes, she said it's people to people, right? Unless you're anti-social, why would you go to Facebook and create an account, right? You expect to create your own networks of friends, fans, followers, circles, whatever, right? But I'm the odd one now. I do create Facebook accounts with no other linkages. You know why? It's like a periscope, and come out and see which student is not handing in assignment. Because he said, I'm dating this one and go out. No wonder they are not submitting assignments. So mine is like a radar checking. All right, so that explains about the 3 types of connections in the cloud. In fact, I don't want to complicate it anymore. From the research perspective, if you checked MIT recently, about 6 months ago, they have announced that they have cracked another dimension, human to plant, right? So you can touch a plant and a plant can tell you what it's trying to communicate to you in terms of weather or in terms of whatever information that their senses has. Okay, so there are more dimensions to come.
May I ask a question?
Of course, you already asked one.
Yes. And another one.
Granted.
How do you say, okay, because the first 2 connections are direct connections.
Yes?
People to people in that respect is not a direct connection.
Right, so the question?
Is that, or anyhow possible to raise that question? To say, is that still the same quality of connections?
No, you're very good. Have you seen my slide?
Oh, sorry, no?
Well, in 30 seconds, we'll get there.
Okay, sorry.
Thank you.
I had another connection, machine to people as well. If you think on bots, it's also machine to people.
Machine to people. And give me an example.
No, if you have a bot in the internet, so...
Oh, the bot can give you... yeah, okay. Well, you can add that as well. But we need to be a little bit clearer so that maybe it all belongs to the big 3 or 4 categories. But anyway, let's don't blur our thinking line right now. And all these connections are proliferating. My second massive open online course, it's on Industry 4.0. You know, I'm very excited about this topic as well. And, you know, there are a lot more sensors being implanted into machines right now, you know, in the daily devices, in our smartphones, in many other things that we may touch on. And these sensors are also collecting, generating, parsing, and sometimes even with firmware and CPUs to analyze a lot of data as well. So with all that, we can only expect more and more connections and more data to come through. A little bit of statistics. I think this is already old, but anyway, researchers have convincingly predict that in the turn of another 3 years, there will be 70 billion connections, right? The connections that we are just talking about. And of course, you know, don't get too overboard. I would say that many of those connections are private, so you cannot mine it officially. But still, even if there's 10% or even less than that, it's publicly available to be searched, to be compared, to be analyzed, to be operated on. That's a huge number of data that we can actually use to study various sorts of things. And Facebook has more than 1 billion accounts as well. So 1 billion account in Facebook, of course, including many are idle, dead, or fake accounts, huge amount. But what are those connections? People to machines, right? So let me go to talk. This is the slide that I once talked about. So taking this reframing, we can call this, you know, a kind of a knowledge cloud, because we start with the fundamentals, the cloud with the infrastructure, with the data, with the connections, with the networks, right, with the printers. You can store data. It has software to compile statistics on the data, to compile statistics on people using it, download, uploads, and all the the ordinary things that you would expect, generate reports. Hi, here comes the people element, right? Because the cloud has installed the software, and people log in and create accounts in those software. So we have this second dimension, we have people and machine. Now further on, we have, yes, as we said, people also create their own circles, their own networks, and so forth. What are these different? Why are these, or how are these people-created networks different from the first two? Well, firstly, these are people-created networks. The first one is hardwired networks, right? And secondly, and very important thing, comes back to KM again. the people-connected networks are built with trust, right? So therefore, in the cloud, there are connections with different levels of trust in there, and we should be able to leveraging. A lot more research needs to be done, but there's ample opportunity to leverage on the trust inside the cloud to do various things you want. What are some of the things? For example, mine the cloud and look for people who are knowledgeable in a certain area. Create a community in that area. Look for people who wants to know knowledge in certain area, and then perhaps feed them with that types of knowledge. Look for people who are experts in certain area and give them incentives to answer specific questions. Many of these, I'll come with examples later, many of these indeed have already been done and demonstrated by American companies, right? Some of the websites I'm going to show you, in fact, is only one of a few out of a few thousand in US that has been operating. So obviously, several years ago, people have thought seriously about this and has taken big strides towards implementing them. So I call this the knowledge cloud. So with this, we have taken a reframing of the cloud, right? The actual turning point is we all agree, just like in KM system, a cloud is not a cloud unless it has attracted a huge amount of people, lots of software, and people are actively using it, right? And that's a cloud. And if that's a cloud, then you have knowledge in the cloud. Then with this reframing, things become a lot more clearer on how we can actually get the most out of this cloud. This cloud is not only just a reservoir of IT and business resources. This cloud has got intelligence, and this cloud can actually, schedule its intelligence and siphon its intelligence to address different types of issues. And I call this an intelligent knowledge center. Why? Because it's intelligent, because it's got business rules, it's got artificial intelligence algorithms, it's got people in there. And these people, some of those are linked up with trust. Some of those may be just part of a network, right, that we need to analyze and see whether we want to use it. And all of these are in the cloud. What does that mean? Go back to the fundamental characteristics of the cloud. What are they? Scalable, right? What are they? They can be provided with very least pre-authorization of management authorizations. So in other words, retaining all those characteristics, we can see that the cloud is a big reservoir of not just business and IT resources, but also intelligence, depending on how we actually access it, how we actually analyze on different parts of the cloud to solve different problems. So here comes with some examples. But before that, sure, AI is advancing rapidly, and as I said, my background was also in AI and expert systems, and AI is coming back in a big way. Make no mistake, there's still a lot of deep learning and also artificial intelligence challenges that have not been met. So far, I have another presentation on how AI is coming back, but tonight is not the right place to use that. But so far, overall speaking, we can say that AI is good in terms of identifying, capturing, discovering the rules, the explicit knowledge, and then programming computers to follow it. But AI is not so good in terms of matching patterns. But matching patterns is more than just matching characters, and we also apply to matching, for example, photos, images, and so forth. And AI is not good in the deep learning aspects, right? So those, until they become more and more mature, I would have to say that a large part of those problems still need to go to human to solve it. So, as human beings, and everyone is, I'm not sure about in Germany, in Asia, people are quite, or starting to get a bit stressful about whether their jobs can be retained or not, because the automation wave seems to be coming through quite amicably every day, every week. Airlines are shedding staff because of they find a way to automate part of their processes and so forth. So, as a human, of course, everyone wants to be remaining as an intelligent human, right? And we don't want to take, in one day, taking instructions from computers. And naively, I can think that the full spectrum of how a human can still perform and be able to make a constructive role start with or span this three. The first one is I can consider each and every one of you as a data point. If that's the case, you don't have to respond have a look here. I can say that maybe you can verify later. I think it's about 55 to 65 people, right? So you become a data point that allow me to count. But of course, you want to be, more reactive. So you can be a sensor, right? If I ask how many people here like Chinese food, how many people here has been to Hong Kong, right? So hands up, hands down, and so forth. You react. You act like a sensor, providing input to the algorithm. But of course, everyone wants to be remaining as an intelligent processor, right? So that the computers cannot solve this problem and continue to siphon those problems for human beings to solve. And we have to remain in that way. And of course, we have to upskill ourselves as well, because there are also clear indications that the skills that universities, again, that's another embarrassing point, that universities are training graduates to come out, it still has, should I say, a kind of a gap before they can become, all of them become immediately employable for organizations and be able to best position to go into the future. Most universities are addressing that, but it takes some years for the realignment. Okay. So, let's go with some examples, all right? How do we actually draw intelligence from the cloud? Here's another funny point. In Hong Kong, at the beginning of the lecture on cloud computing, I need 10 minutes to teach my students English pronunciation, right? 3 words: cloud, the sky; crowd, a group of people; and cow, animals, because they cannot pronounce it properly, and kind of, the embarrassment to people when you cannot pronounce it properly. All right, so a little bit about what I've said before. Nothing new here. When we have a problem on hand, especially if it's a complex problem, and increasingly we have to face complex problem, right? That's the inescapable. That's part of knowledge work all around us. So if it's a complex problem, we constantly ask, as well as trying to rely on the embedded intelligence in the cloud to decompose, if possible, whether any part of that complex problem can be solved by machines. And if that's the case, we farm it out to machines to do. So, I'm not an expert on supercomputers, but I'm led to believe that, for example, calculation of ocean temperatures and prediction of weather forecasts and all those things, it requires a huge array of computers to crunch through. So those, in the short term, probably will still farm it to computers to do. But there's an awful amount of tasks that computers cannot do, and still cannot automate, and it requires human input to varying extent. So for those, we should bounce it back to Earth and ask humans. At this time, we can bounce it back on Earth and ask millions of humans to solve, because it's via the cloud. We can also be selective and bounce it back on Earth and ask a selective group of people to answer. Right? For example, if I want to, if I go out to and ask about, anybody can tell me about the future of higher education in Germany, right? So we are right now in a university campus. Of course, being able to get a response, no matter what the quality of the response, is higher than I just asked this question on the general street, right? Because the group of people here tends to be more educated or oriented, right? So there you go, the same thing with the cloud. When we have to ask a question and ask the people in the cloud to solve it, we have the option, assuming that we have access or we can develop the tools. In fact, some of the tools are already available to selectively approach different groups of people and to solve this problem with different chance of success and different quality, right? So the opportunity is, the limit is, I got all mixed up with this cloud sky and all these things, right? But you see what I mean. All right, so more examples. So this one is, we take it to the extreme, where this problem cannot be solved by computers and everything has to go to human beings, all right? So what is it? Very simple, very simple. Computers are not good or not fast in recognizing images, right? Human eye immediately can tell. So anybody, just look at the last one. Galaxy Zoo. Galaxy Zoo is a website that asks people who love to look at star systems images, right? You have to go to high sky, very dark, and you've got to have a very long telescope, have your gear ready, and pick a clear sky to enjoy, right? So they constantly put pictures there. They ask, people, for example, if they ask you, would you like to, to cast an opinion? Have a look at these 5 pictures, right? And they ask about, is there a star system? In other words, is there a spiral, in the picture? And if there's a spiral, is there a clear direction that you can tell where this spiral is spinning? So here we go. On the top left, is there a spiral? Yes, but can you tell the major direction? No. Top middle, is there a spiral? Yes, it looks like it's counterclockwise. Is that right? A third one, top right, is there a spiral? Well, there's 2 spirals, but we can't tell whether there's a dominating one. Bottom left, is there a spiral? Quite obvious. And it is spinning clockwise. Bottom right, there's no star system talked about. Okay, stop. How much time we have used to run our human eyes over those 5 photos? Less than 20 seconds. There you go. For that sort of problem, you go straight to humans. Because even with the might of supercomputers, whether it's US defense or the China defense, they cannot solve and recognize these pictures in the flesh of our eye, right? So those problems will continue to have to go to human to solve it. What, you think that's new? Not new, unfortunately, because Amazon, the Americans, they've already thought about this. So Amazon's pet project is started about 8 or 9 years ago. You can go and sign up an account in there, right, and make yourself connected with the Amazon cloud. Amazon Mechanical Turk. It's a website that's set up to do exactly that, right? So you have some tasks that you want people to solve for you. Of course, we are all KMer, depending on which side you're on, depending on what you think, you may or may not need to give incentive to people in order for them to tackle your problem. Fine, even if you don't want to order incentive. Most of the incentives there, I had a look, it's 1 cent, 2 cents, or at most 5 cents US for people to respond, right? So you can declare your problem, what it is. You can identify the people, the groups of people, with no names, of course, that you will invite them to tackle your problem. You can define the starting period. You can define the ending time. So after this date, no matter what your input, I'm not interested, right? So farm out your problem there and ask millions of people to respond. Or maybe up to a certain limit, you cut off, that's it, I've got enough, right? So just have a quick look down the left-hand side, for example. There's a snapshot of some of the tasks going on. There are 6 here. Half of those shows what sort of task is it? Classification, categorization, is that right? So, I can't jump to the conclusion, but it kind of leads us to think that computers are not terribly good in classifying things, right? Maybe it lacks a context. I do some work on taxonomy, and that's surely right, in the library area on taxonomy, classifying things. Classifying things, in fact, is only one side of the coin, because it depends on how the user will access the information, right? So therefore, without this context, computers are difficult in doing classification. There's nothing absolutely right in classification. It all depends on how successful the user can retrieve it, right? Okay, what about the others? If you look at the second last one, what is it? Is it too small or people can read? Inspect people's record, is that right? Well, that can be put up by the police department, by to investigators, by private investigators, by anybody, right?
What does it actually mean?
What does it actually mean? Yeah. It will ask you to...
I don't quite understand what task it is.
Inspect people's records. Yeah. So we give it a name and ask to find as much information about this person as possible.
Okay. Mm-hmm.
Yeah. I get it. Obviously, the person who are offering this service is expecting the answer to be a lot more deeper and more comprehensive than just a Google search, right? And the last one is this person a musician? Well, the answer seems to be simple, a yes or no, but not the might of Google can give you a yes and no. Again, it needs human input, right? Google is catching up with all the search cards. For example, I can just talk to my phone, when is the next flight back to Hong Kong? Amazing. It actually will. It doesn't tell you whether it's got seats or not, but it can tell you which airline and what time it departs. So the search is catching up with what we call Google cards, right, and search cards. But it's still a long way from here. Well, another one. I think most people would have seen this kind of patterns before. Recaptcha. Recaptcha is the name of the firm. Anybody know what it does? Was that an answer somewhere? Recaptcha is, sorry, I didn't get that. But Recaptcha is a machine translation firm, right? It's a spin-off by two graduates, PhD graduates from Carnegie Mellon University. So they set up a company to scan like mad, 24 hours by 7 by 365. So there's bound to be something that every now and then these algorithms cannot tell, right? So they have lined up a service with various websites and asked humans, whenever appropriate, to help them to decipher. So in other words, do you know that in fact behind the scene, the computer, the Recaptcha computer, only know the answer to one of these two words? It is using us to tell it the answer to the other word, right? Very smart, right? So how does it do? Well, simple. I mean, I don't work for them, but based on what I've read, for example, as a scientist, you can fine-tune your computer program that if 50 people say that the right-hand side word is this one, then trust it. Of course, this may not be absolutely true. Maybe you still need to run the eyes on a human, by a human, right? But it is making use of that opportunity and leveraging on human input to solve the problem and continue. And in fact, Recaptcha's CEO actually came out and said that thank you to the world. Together, you are helping our company to save $1 million a day, right? So everyone has been helping. And there are more of this, right? Many of the language translation websites, in fact, there is no human behind them. It's scary. It's using, peer input, enough peer input to justify that that is the right translation. All right, so allow me to finish it off in about 10, 15 minutes. Is that okay? Right, so I think that to proceed with this, we should not just blindly, just like in the AI days, converting what we know, although we know that it's not possible to do all of it, our tested knowledge, our domain knowledge, into the cloud, right? In fact, we have to hold back. Something we have to, step back, and reevaluate, because some things we even have to unlearn and do it all together. So a number of examples to trigger our thoughts so that we learn from big data. What are those things that we should not directly copy for trying to transfer from our mental model into the cloud? First one is, again, case study. In 2009, Google works with America's CDC, Center for Disease Control. And the CDC is set up to monitor the potential outbreak of epidemic disease. Hong Kong, unfortunately, in the last 10, 15 years, had a big one, at least one big one called the SARS, right? So Google went back to analyze all those data that people typed just before the official outbreak was announced, right? And they've crunched through many, numerous millions of mathematical models. I would say that only Google can have the power to do it. And amazing, they still have what we actually type into search 20 years ago, if you have signed up with Google and used your name to search. So after all that analysis, now Google holds on to 40 keywords and terms that people commonly type into the search engine box to find out whether they have caught a disease, right? What's the theory? The theory is if you know that there's already an epidemic outbreak, whether it's in Africa, in America, or whatever, and you start to sneeze, you start to have what you believe can be some of the symptoms, you may do a search on Google to find out what the real symptom is like, right? To see whether you got the thing, right? And doctors also confirm that, in fact, if it's an epidemic outbreak, you've got the disease. It does not mean that you will immediately sick. You may be immune. You may not be sick eventually, right? There's a hibernation period. The hibernation period may last for a week to 10 days or something like that. So clearly, shortly after you have caught the disease, you are still walkable, workable, travelable, and so forth. So, but we start to feel that something is coming on and bringing down your body, you may do a search, and for that moment, Google may get you. Why? Because they then notice Unusually, around the vicinity of a city or an area in a particular country, there are more people, unusual number of people typing in those queries, right? And that's a signal for alarming something. And Google confessed that this is over-detecting. It's over-detecting. They're still fine-tuning it. I'm not sure whether they're still deploying it. They're surely fine-tuning it, and they confess that this is over-detecting. But in today's, the epidemic, outbreak prone area, I think over-detection is better than under-detection. But with this case, what does it highlight? What does it highlight from big data? Well, to me, it's very refreshing because for CDC, this can be quite embarrassing because the early detection is not from them. The early detection is based on system from an IT company, right? Or from Google, right? It can completely bypass all the medical systems, clinical systems that the CDC has, right? It's from a third-party source. And in big data world, in the age of digitalization, we must offer that alternative thinking as well. Not just your data, but other types of data. This can be very real, while you're still typing. I don't think it's Germany, it's only deployed in America. When you are still typing, someone dressed in protective uniform knock on your door and take you away, like in a movie. Second one, we look at the third one, okay? Do you know, again, buying a second-hand car in America, 40 years of research data, and these data are authentic, checked thoroughly, and cannot cheat. They are not wrong. 40 years of research data indicates that if you want to buy a second-hand car in America from the official dealers, right? I suppose you want to buy a very reliable second-hand car. Do you know you don't even need to test drive the car? You don't even need to touch it, right? You just need to find out what's the color of the car, right? And that is, 40 years of data indicates that there is a high correlation between the orange car and a second-hand car that's being sold with least after-sales services, right? So for the science mind, including myself, among all of us, engineer and science mindset, what are we thinking? Why, right? We're trying to think about the causal reason, the causal relationship. Until we figure that out, we're still, up to now, I can confirm that there's no scientific proof to prove this, right? So, but then, if you are competing in a world with only strategic or a short strategic window, someone would have bought that car while you're still thinking about the why, right? So it's up to you, okay? A third one I can talk about, Google Translation. But before I talk about it, everyone have used Google Translation. What is your impression about Google Translation? I suppose, should I assume that German, English, German are the most commonly used here?
Not very good.
Not very good. Any others?
Got better.
Got better?
Yeah, but better because you have now choices to select what kind of terms you want to be translated in which.
Okay. Well, I kind of get exactly what I want to have. Anyway, the Google Translation feedback usually is some say that it's all right. Some say it's good for some sentences, but some say that it's shocking. All right? You know why? Well, I fell into that trap as well because being an artificial intelligence researcher, the mainstream method of doing translation or natural language interpretation is to build language parsers, a software that actually parse a sentence into various tokens: noun phrase, verb phrase, subject, object, transitive verb, agents, and so forth. If you can decompose a sentence into those, then there are lots and lots of rules and background knowledge that you can identify who is doing what. Then you're trying to enable the machine to better understand that sentence and then do the translation. Does Google follow that? No, no, and no, right? Google doesn't do all this, they bypass all that. So how did Google do the translation? Well, Google declares that, in fact, they look for public websites that has page-to-page exactly translated in different languages, right? So these are obviously being done by humans. These are obviously being done by very professionally qualified humans. And for every character, every word, every sentence, they are correct. Okay, where do you find these websites? Typically, government websites, right? U.S. government, UK governments, I suppose South American governments. So many of these government websites, they have got pages and pages of these automatically, or not automatically, manually translated, and then with their, their content management system, they have different pages ready in different languages. So Google scan all that and then remap each sentence and phrase to each one. So that explains why some people say that, it's a perfect translation. If that is something that's very close to a sentence, that's already used among the tens of millions of pages that they have scanned. And very bad if it doesn't match anything close to there. So that explains it. So what's the learning from this one then?
There are limits.
Of course, there are limits. Any others? What's the learning from this? Hearing about how Google does the translation. Maybe you rely on carefully crafted pre-existing data, rather than going to, or in addition, or rather than going to a traditional way of encoding the software. Firstly, that may be too slow. And secondly, you still have to solve a barrage of problems, right? So very smart, very smart. Okay. Well, there are many other data-driven predictions. Some of those are more obvious than others, but many of those are also surprises. So I'm just saying that in the age of digitalization with big data, many things that we just cannot foreshadow. When data shows that there is a strong association, perhaps in the short term, as long as we have verified it, we have to trust it, right? Until we have a causal explanation. Okay. Maybe just briefly about this one, and then I'll wrap up. The man you see here is Dr. Jay Lee, and Professor Jay Lee. He is president of the NSF in America, in Cincinnati University, also a professor in our department. And the reason I put it there is because the book on top of his photo is Industrial Big Data. Now I believe there is an English version. But that book, when it first came out, for several months, was the biggest selling big data book in China, right? So he set the scene there. And he shared us one case study. Obviously, he worked with in America. Dr. Shou has his products in Germany as well. What does he sells? Well, he sells soles, cushions that he put it on your shoes, right? So Dr. Shou is a foot specialist. So he would have seen, I suppose, tens of thousands of patients, and he has lots and lots of data. So what he has done is analyze the data in his medical records, and then come out with the device working with a company to measure people's foot pressure. So he asked people stand on that machine and measure your pressure on your foot in different parts, and then he recommends you to go around on the other side of the shelf. To pick left-hand side, you need a sole of this particular scale, and right-hand side foot, you need a sole of this different scale, all right? So obviously that would be more customized and more comfortable, right? So this is a brilliant working case studies, and Prof. Chen told me that, Prof. Lee told me that if you just want to get the general one, you don't need to step on the machine. You can't, because I think he asked you to swap the credit card first. You only pay $20 US, but if you want a personalized diagnosed combination, you need to pay 50 US. Right? So, end to end, from good ideas, data, good ideas, and operationalize it into almost a standalone device to charge money, right? Wonderful. So allow me to wrap up. So what are some of the things that we have to unlearn? I call that rewiring ourselves so that we can build better logic and better intelligence into the cloud. And it's nothing new here. The speed of making decisions in the cloud is a lot faster. We have to go for approximations very often rather than just go for exactness. We should also consider using alternative data, which can be giving us a better leadway into the prediction, right? Rather than just using existing ones. Sometimes even more accurate. And also leverage on data information that are carefully being pre-generated by people. In fact, many of these data can be free, can be publicly accessible, right? So don't lose sight of that as well. This one I also find it to be, for myself, to hard to understand, well, hard to follow, you know, because I was a computer scientist as well. But big data's researchers are saying that if your program doesn't work, sometimes don't throw away the data, don't change your program, find other sets of data because your program may work for other lots of data. You're only testing your program on small data, right? So very nice. Okay. Looking into the future, I think for all KM researchers and practitioners, we will very soon be leveraging the cloud to provide our services, right? A lot of services we talked about, sharing, collaboration, identifying expertise, building a community, answering our questions, and so forth. So, you know, what's the shape of, KM systems and knowledge services coming through? Like a vending machine, you know? Everything is X as a service. And we already see that happening, right? You can see that in App Store, there are new apps coming out that are allowed to build your service, to combine your service. In Hong Kong, the Citibank also released services in API that allowed, third-party companies to embed these APIs into their own software so that they can access Citibank services, right? And there's no reason why knowledge services cannot be engineered in this way and work with different parties. So finally, I would recommend organizations that adopt dynamic capabilities using resources inside the cloud in order to extend their capabilities in real time, whenever it is needed. We should engage in deeper collaboration, more than just using the common software, but co-creating, co-designing, and co-assessing various things. Cloud-based services is the future to go. They're already coming out. Data-driven decisions become a new source of knowledge. That's pretty obvious, right? And KM has to acknowledge this important new source of knowledge as well. Look no further, but look at maybe you're sitting on a chest of gold, in your organization. Leveraging on existing public historical data. And again, sharing is powerful. Continue to share your algorithms, data, and tools. Why? Because of leveraging that combinatorial effect, rather than just contain it by yourself, which will never multiply the success and accelerate the speed of achievement. Well, I believe researchers, AI researchers, CIOs, and process experts are at the forefront of this exciting era because they are constantly in discovering or deciding the redivision of jobs and decisions between machines and humans. Yesterday, I was at University of Potsdam, and Professor Grono's work is precisely on this. He's conducting research into identifying to what extent machines could continue with the automation. In other words, to what extent human interventions should apply, right, in order to gain the most. And the most needs to be properly defined as well, not just in terms of lowering costs and automation. Well, if you want to hear more about my, my lectures, I ask you to turn to edX, IC101X, and for 2 years I have been broadcasting not only in YouTube but also in MIT edX massive open online course. And we talked about big data, we talked about KM. It's about 6 lessons with 150 videos with lots and lots of international case studies in there. It's free if you don't want a certificate. If you want a certificate, signed by me, but the money collected by the Americans, US $50 from MIT and also PolyU. With that, I'd like to close the Horizon speech and take questions. Is that right? Thank you.